Hello, my name is Ian and I'm a tutor at Chegg. Today we're going to be talking about implicit differentiation and related rates. First, let's start off with implicit differentiation. So the general rule you'll use here is dyn over dx equals ny n minus 1 y prime. This should look very familiar to you. This is basically the chain rule. So you have your outside, where you have n minus 1, and then you have to take the derivative of the inside, which in this case will be y prime. So let's try a problem. We have x squared plus y, or x plus y squared over x squared plus y equals x squared. So the reason why this is implicit is the fact that y is on the same side as x. It's not directly saying, hey, find the derivative of y in relation to x. Like if you had y equals x squared plus 2 or something like that. So whenever you have your y's with your x's, you know you have to take an implicit derivative. So let's go on from here. We know we're going to have to use the chain rule as well as the quotient rule because here we have a rational function. So first, let's set up the equation. You have the derivative of the left side equal to the derivative of the right side. So a mnemonic I use for the quotient rule is low d high, high d low, because that tells you to, the first is the low, so x squared plus y, the derivative of the high, so x plus y squared, minus high, so x plus y squared, derivative of low, so x squared plus y. And then it's all over x squared plus y squared. And then on our right side, we have the derivative of x squared. So from here on, we now need to distribute. And in this particular case, I partially distributed, and I'll explain that just in case you weren't taught that. So here you see that I also have the x squared plus y squared crossed out here. That's because after we take the derivative of the top, cross it or multiplying both sides by the denominator makes this so that the denominator cancels out, and therefore we'll no longer be dealing with a rational function, which can be kind of nasty to deal with sometimes. But let's talk about the top now. So we have x squared plus y. This was left alone because we weren't taking the derivative. Then we have 1 plus 2y, y prime. We had x here, and therefore, being there was only one x, you'll have a 1 here. Then we had y squared. So you bring down the 2, and then you have y. And then because you need to take the derivative of the inside, you have y prime. And then minus x plus y squared. And that's being left alone here as well. And then we have 2x plus y prime. And that's because we have x squared. So you bring down the 2, and you have x. And then you had just y here. So since you're taking the derivative of that, you'll have y prime. And then on the right side, being we multiply both sides by the denominator, thus canceling out the denominator on the left side, you have 2x times x squared plus y squared, the whole thing squared. So then, as I said here, I do a partial distribution. To explain what's going on, if you have a plus b times x plus y, then you can have a plus bx plus a plus by. So that's basically what I ended up doing here. I labeled the appropriate parts. You can distribute fully, that's fine, but in this particular case I didn't have to, so I did not. So moving on from there, the distribution. If you have y prime, you need to have all of your y primes on the same side. So in this case, we have a y prime here, 2yx plus 2y, y prime, and one here, negative x plus y squared, y prime. So they need to stay on the same side. For here, I'll have them on the left. Everything else has to be moved away from the y primes. So here, we have everything else on the left side. So we subtracted x plus y squared, and we have it here. And we also added negative 2x plus y squared, and now we have it here. And the reason why we added here and subtracted here is because this was positive and this was negative, and to cancel it out, you need to use the opposite operation. So now that we have all of this here, That's great. Now what do you do? How about you take a second to think about what you have done with algebra in the past and think about it. If you didn't get it, that's okay. So we were just here on this step. The next thing you can do is you can factor out a y prime, because y prime is in both of these. And if you distribute, you get 2x squared y plus 2y squared minus x minus y squared. The next thing that you can do is distribute. So we have 2y times x squared plus 2y y prime. So we already said that you can factor out the y prime, so that's why y prime is here. So we have 2x squared y. Where did that come from? You multiply 2y by x squared. Therefore, you get 2x squared y. Then if you multiply 2y by 2y, you get 2y squared. We open up these parentheses here, and we get negative or minus x, and then because this is a plus here, and this negative carries over, you get minus y squared. And then on the outside, being we factored it out, we have y prime. And then on our left side, we have 2x, x squared plus y squared, minus x squared minus y, and that's because this was a plus 2x squared now because you multiplied this by the x in here, plus 2xy squared because you multiplied 2x by this y squared. So now, what do you think we'll do next? If you guessed that we will combine like terms, you are absolutely correct. So once we combine like terms, we get 2xy plus y squared minus x with the y prime factored out. And the reason why we have only plus y squared is we had plus 2y squared and minus y squared. So 2 minus 1 is 1. So on this side, or on the right side, we then have 2x, x squared plus y squared, plus x minus y plus 2xy squared. And the reason why we end up with minus y is similar to, or the x squared instead of the 2x squared and x squared is 2 minus 1 is 1. So you end up with x squared. And then we still have this issue here with the y prime. We want to get y prime all by itself. So with that in mind, it makes sense to divide both sides by 2x squared y plus y squared minus x. And in doing that, you can get y prime by itself. So then we have our final answer here. Y prime equals to 2x, x squared plus y squared, plus x squared minus y plus 2xy squared, all over 2x squared y plus y squared minus x. Of course, you can bring this further, but for the sake of time, we're going to end that part there. So the next part we're going to be talking about, this is idea of related rates. Related rates uses that idea of implicit differentiation, but usually with word problems. So for word problems, you need to be able to fish out what the important things are. So the important things to help you if you're working through a problem in the future, I have highlighted here so that you can visualize them. Since I know some people are colorblind, I tried to use a pretty neutral color, so they should be purple. But a car is leaving an intersection traveling east. Its position 6 seconds later is 30 feet from the intersection. At the same time, another car leaves the same intersection heading south, so that its position 6 seconds later is 23 feet from the intersection. If the speeds of the cars at that instant are 12 feet per second and 9 feet per second respectively, find the rate at which the distance between the two cars is changing. Wow, how are you going to go about this? So first of all, we have that one car is traveling east and another car is traveling south. So that means we have a triangle that looks something like this for the intersection, because one of them is heading east and one of them is heading south. And we know that the one is heading east is going 12 feet per second, and after 6 seconds, it has gone 30 feet from the intersection. Similarly, we know that the car that's heading south is going 9 feet per second and is at 23 feet at the end of the 6-second period. So if you think back to pre-algebra, this should look very familiar to you. what formula could you use to figure out h in this case? If you set the Pythagorean theorem, you're absolutely correct. So let's look at this. We want dh over dt at the time of 6 seconds. So how do we know this? Well, we don't know what h is, so that's why we know we want dh. And t, we know it's over dt because it's asking about time. Find the rate at which the distance between the two cars is changing. And it says at that time multiple times throughout the question. So we know that the Pythagorean theorem is a squared plus b squared equals c squared. But to keep with the idea of implicit differentiation, let's use x squared plus y squared equals h squared. So now that we know dh dt at the time t of 6 seconds is what we're looking for. This is our equation. Take a moment to think about how you would solve this. If you didn't get it, that's okay. What we'll have is we need to take the derivative of x squared, y squared, and h squared. So we know to take the derivative, if we use a power rule, we bring 2 down. And then we have x to the derivative of x over the derivative of time, plus 2y, bringing the 2 down, to the derivative of y over the derivative of y in relation to time, equals 2h with h in relation to time. So we know that. So what would you think about doing now? We need to get y by itself. So if you remember before, what we did is we divided the sides. So if we divide each side by h, so I had the mouse in the wrong spot. You want the dh dt because remember, that's what we want. We want dh dt. So if we divide both sides by 2h, so 2y divided by 2h and 2x divided by 2h, we get the following. xh, the two 2's cancel out, therefore we now have a 1 in front of the x and the h, times dx dt plus y over h, same idea, the two 2's cancel out, dy dt equals dh dt. So we know what x equals, we know what y equals, and we're trying to figure out h, so what do you think you would do here now? Take a moment to think about how you could potentially solve this, knowing what the variables equal. Again, if you didn't get it, that's okay. So at time t, 6 equals h squared plus 23 squared plus 30 squared. After you calculate that, you get that h squared is about 1,184, so h is approximately 37.8. Knowing that, we're almost to our last step. We just need to plug everything in. So how about you try plugging in the different values for the variables and see if you come up with the correct answer. If you did not, that's okay. This is just good practice for you. It's okay to get it wrong now. That way you can get it right when you do your homework or when you're in class. So we know that x was 30 and our h is 37.8. And the car was moving at a rate of 12 feet per second. And then we add 23 because the car was 23 feet away from the intersection at that point, over h, 37.8, and it was moving at 9 meters per second. Once we add all of that together, after the multiplication, of course, we get that the cars were moving at 15 feet per second we're changing distance from each other at a rate of 15 feet per second for dh dt.